Ideal gas is the theoretical gas composed of molecules that do not attract or repel each other. Ideal gas is only ideal in the sense that it conforms to the perfect gas law. Gas laws such as Boyle's law and Charles' law. Boyle's law states that the product of the pressure and volume are observed to be nearly constant. And Charles' law states that volume of a gas is directly proportional to the temperature. If the temperature of a given quantity of gas is held constant, the volume of the gas varies inversely with the absolute pressure during a change of state. In the formula, volume is inversely proportional to the pressure, or B is equal to C over P, where C is the variable for constant. It will be equal to P times B is equal to C, or P1 B1 is equal to P2 B2. In Charles' law, if the pressure of a particular quantity of gas is held constant, then with any change of state, the volume will vary directly as the absolute temperature. As in the formula, B is directly proportional to temperature, or B is equal to CT, or B over T is equal to C, or B1 over T1 is equal to B2 over T2. If the volume of a particular quantity of gas is held constant, then with any change, the pressure will vary directly as the combining Boyle's and Charles' law, it will be P1 B1 over T1 is equal to P2 B2 over T2, which is equal to constant. PB over T is equal to MR, or PB equal to MRT, where P is the absolute pressure, V is the volume, M is the mass, T is the absolute temperature, and R is the specific gas constant, or simply the gas constant. The specific heat is defined as the quantity of heat required to change the temperature of unit mass to 1 degree. Specific heat represented by the variable lowercase letter c, which is equal to the heat over mass times change in temperature. Constant volume is specific heat, where heat is equal to change in internal energy. Q is equal to mCb T1 minus T2, where volume is constant. Then, constant pressure, specific heat, Q is equal to mCp T1 minus T2, or Q is equal to delta U plus W, where W, or work, is equal to the integral of P dB from 1 to 2. That will make Q is equal to delta U plus P times B2 minus B1. If we expanded it, it will be Q is equal to U2 minus U1 plus P2 B2 minus P1 B1. As enthalpy is equal to the internal energy plus the product of pressure and volume, we can substitute enthalpy for, it will be Q is equal to H2 minus H1, or the change in enthalpy. K is the ratio of specific heat, and it is equal to Cp over Cv, which is less than 1. The ratio of specific heat cannot be over 1. Internal energy of an ideal gas. Joules's law states that the change of internal energy of an internal gas is a function of only the temperature change. Therefore, delta U is given by the formula delta U is equal to mCb T1 minus T2, whether the volume remains constant or not. Enthalpy of an ideal gas. The change of enthalpy of an ideal formula delta H is equal to mCp T1 minus T2, whether the pressure remains constant or not. The relationship between constant pressure specific heat and constant volume specific heat. From the formula, H is equal to U plus PB, and PB is equal to RT. dH is equal to du plus R dt. Where dH is equal to Cp dt and du is equal to Cv dt. The constant volume specific pressure will be equal to R over K minus 1. And the specific and the constant pressure specific heat is equal to K R over K minus 1. Entropy is that property of a substance which remains constant if no heat enters or leaves the substance, while it does work or alter its volume, but which increase or diminishes should a small amount of heat enter or leave. The change of entropy of a substance receiving or delivering heat is defined by ds is equal to dq over t. By integrating it, it will be the change in entropy is equal to d derivative of q over t from 1 to 2, where dq or derivative of q is equal to heat transferred at the temperature T.